All right, so 3.8 in our pre-calculus and foundations of math 10 talks about two things. The first thing is perfect square trinomials. So this is a lesson on perfect square trinomials. What is a perfect square number? Let's talk about a perfect square number first. Is 25 a perfect square? Yes, it is. And now why is that? Because what? Okay, because we take the same number and multiply by itself, right? That means it's a perfect square number. What are two other ones, just off the top of your head? 36 and 49, okay. Now 36 is 6 times 6, 49 is 7 times 7. So you got it right. The thing is there's two identical factors, right? And we could write this also as 5 squared. And if you can write it in terms of to the power of 2, then you have a good idea it's a perfect square. All right, so that's perfect square numbers. What about perfect square trinomials? Here's the thing. If I take this same concept and let's just build a perfect square trinomial, okay? It means that we have two identical factors. So watch this. If I take x plus 2 and I multiply x plus 2, those would be identical factors. Let's just see what the result would look like. Now, you've all been well versed in the distribution method, right? Or the FOIL method of binomial expansion. So let's do this in our heads. What is the answer here? Well, x squared plus 2x plus 2x plus 4. So it's going to be x squared plus 4x plus 4. All right, let's do another one. Let's do one that's a little more complicated, like 2x minus 3. And let's multiply that by itself. Okay, so here's a little exercise to see how well you're doing, if you can do this in your head. Okay, what's 2x times 2x? That is 4x squared, good. And we have then negative what? 6x, and then another negative 6x, which is negative 12x, and then positive, or plus what? No. Okay. Now, it is helpful to note, I think. I'm just gonna show the expansion here. This was minus 6x minus 6x, right? That's another way to put that. And this actually is going to be pretty important when we uncover the characteristics of perfect square trinomials, all right? So let's just do one more, okay? Let's do 3x minus 1 squared. Now, this is going to be a little bit trickier for you to do in your head, but I want you to try it with me, okay? Let's not expand it, and let's see if we can do this in our head. So the result is going to be 3x times 3x. It's going to be 9x squared. Then we're going to multiply this out to what would be the second factor, and we're going to do 3x times negative 1. And we're actually going to do that twice. So that's going to be negative 3x, negative 3x. And then we're going to multiply the last term times what would be itself, plus 1. Okay? So that's 9x squared minus 6x plus 1. All right, so that's good, I think, for a few examples. Now what I want you to notice here, all right, what I want you to notice are the similarities between the trinomials that result when we multiply two binomials that are identical. And what you should notice, well, actually, let me ask you, what do you notice about each of these that I'm now highlighting? What do you notice about them in general? Kind of as a, whoops, let's do this one instead. As a category, what do you notice that all three of these have in common? What are some things that all three of those have in common? Anybody? Yeah, sure. What was the question? Okay, the question again was, what do all three of these? Here's 1, here's 2, here's 3. Don't look at these over here for now. I want you to look just at these trinomials. What are some similarities? What do they have in common? Somebody there? Okay, they are all perfect squares, right? That's exactly right, because they came from two identical factors. Yes. Now, what I really want to get to is what are some characteristics of perfect square trinomials? So what do we see that, any other observations? Okay, let's get down specifically. Anybody? Coleman, do you have a? Okay, let me help you a little bit. Look at this. I'm going to highlight these now, okay? Look at this number and look at this coefficient here. Look at this coefficient, this one. Okay? What do all of these numbers have in common? And of course, this would be a 1 if we would show it. Those are what? Those are all what? What are they? All numbers. Okay, thank you. Anything more specific? Wow. That's good. Really? That's what I got? They're all numbers? Sorry. Yes, they're numbers. Congratulations. Okay? Here's the crayons. Don't eat them. Okay? Okay. Okay, so a little bit deeper. I'm looking for a little bit... Sorry, I was a bit sarcastic. I apologize. Funny, but inappropriate. Okay, so here's what I'm going for, guys. Look at... I mean, come on. Let me circle these. Does this help? Does this help? They're all positive. Okay. Anything else? Help me out here. Do you know? Oh. Yeah, do you know? Okay, wait. We've got... The first one is x squared. The last one is just a constant. Okay? Yes, that's not what I'm looking for. Okay. That was a good exercise. Let me just tell you the answer. Okay. Yes, discovery learning. It's awesome. Okay, so look at these. What I'm getting at, guys, listen. These are all perfect square numbers. Okay, I circled over here the perfect square numbers. 1 is a perfect square. 1 times 1. 4 is a perfect square. 9 is a perfect square. Got it? They're all perfect squares. That's what I was hoping somebody would say. Now, when we look at a trinomial, what I'm going to ask you to try to figure out is it a perfect square trinomial? All right? And one of the things you look at is you look at the first term's coefficient and the last term. If they are perfect squares, you may have a perfect square trinomial. Because you cannot multiply two identical factors that are binomials like this and get numbers at the end or numbers that are coefficients in the front as anything but perfect squares. Okay, so what I'm saying is that if you had 3x squared plus 10x plus 16, that is not a perfect square trinomial. I know right away. How come? Because the 3 is not a perfect square. Okay, so that's not a perfect square trinomial. So that's the first level of things that I want you to understand. Got it? Okay. Now, let's go back, because I want to develop this a little bit further. So let me just erase this. So the other thing that you might notice, okay, is that, this was maybe a bit of a stretch, but what about these middle terms? What about the middle terms? Now, there's levels to this, but what do you notice about these middle terms? And you can look at the factors here if you want. Sorry? Any observations? Yeah? They're not perfect squares? Okay, well, 4 is. Yeah, 4 is, but they don't have to be perfect squares. I'll take that, yeah. Okay. They are all even, which is important. They're all even, okay? So in a perfect square trinomial, you can say that these middle coefficients are all even. But what's deeper, I want you to notice this, is that what is the square root of this number? Oh, it's 1. What's the square root of this number? That's 2, okay? The square root of this is 2. The square root of this is 3. All right, the square root of this one is 3. The square root of this one is 1. Okay, so we've got 3 and 1. Here we've got 2 and 3. And here we've got 1 and 2. Okay, what you probably wouldn't have noticed, and again, I want to speed this lesson along here, is that 2 times 1 is half of this. 2 times 3 is half of 12. 3 times 1 is half of 6. So, if I doubled the square root of this, doubled it, I would get the middle term, or the middle number anyways. Okay? Now that's a deeper level of observation that I don't really expect you to have noticed. But these are all pieces to the puzzle. Okay? So, let me give you some examples here, and a couple more examples, and then we'll just see here, okay? All right. All right, so this one here, 4x plus 12x plus 9. Now, okay, that's very close to what I did up here, isn't it? Do you see the one that's very close to that? This would be squared, right? So could this be a perfect square trinomial? Could it be? What are we looking for? Is this a perfect square? Yes. Is this a perfect square? Yes. So it could be. Is this even? Yes. Okay, so these are all good things. Now, what is the perfect square, or the square root, I mean, of 4? 2. Okay, so let's just, for kicks here, let's just see if it's a perfect square. The square root of 4 is 2, and of course the square root of 4x squared is 2x. What's the square root of 9? 3. Okay. If you throw those down there and you say, I wonder if this is a perfect square trinomial, if you just try this by starting with the square roots of these numbers, would this work? So if you do a quick FOIL in your head, is this the factored form? Well, we have 4x squared, we have 6x, another 6x, there's just 12x, and then 3 times 3 is 9. So yes, that is a perfect square trinomial. Okay? So some of this you're going to be able to do a little further in your head. Okay. So there are some characteristics that you might be able to recognize. Okay. What about this one? 9x squared plus 10x plus 16. Could this be a perfect square trinomial? Is this a perfect square? Is this a perfect square? Is this even? Yeah, okay, so right now it passes all of our tests so far. So let's just see. What you want to do is just go, hey, 3x and 3x. That's the square root of this term. 4 and 4. That's the square root of that term. This is positive, so that means that these both have to be negative to multiply to a positive, or they both have to be positive. This sum is positive, so let's try positive. So let's see, does this work out? Does this check out? The middle term is what's in question here, right? So that's, the middle term comes from 12x plus 12x. Does that give us 10x? No. So here's an example where this is not a perfect square. See that? What would I have to change from this original trinomial? What would I have to change to make it a perfect square? And I did part of the work here for us down here, right? What would have to change, or what could change to make this a perfect square that might be factored this way? What would have to change? Obviously the 10 didn't add up, right? So what number should this be in order for this to be a perfect square trinomial? Because this is the next level here that I need you guys to understand. You're going to have to be able to put a missing piece in there to make it a perfect square. Did you say something? 24, yeah. Didn't we just talk about that? Look at this. 3x times 4 is 12x. There's another 12x. So if you add those together, if this was 24, then this would be the factored form. Got it? Okay. So perfect square trinomial, that is a special polynomial, and there, you can factor a perfect square trinomial pretty quick, realizing that the factors will be identical.